Okay, welcome back. Good morning, good afternoon, good evening, whatever time it is for you watching this video. This is Mr. Jodry again, and today what we're talking about with this flip is the law of cosines. So once again, this is one of those triangle methods where it's not a right triangle. That's the point of this method. Okay, so here's the law of cosines. This is pretty much a generalization of the Pythagorean theorem. Now, we'll talk more about this in class Tuesday on why this is, but this is pretty much just a generalization of what you already know from 7th grade and probably even before then. Okay, let's explain what all this means. Okay, here's what this law of cosine is really talking about. Say I got a triangle ABC, and these letters are kind of arbitrary, so we're just going to put these as placeholders more, A, B, and C. We'll talk about this more with words, if anything, than letters. So here's what this means. You always want to start with the angle you're working with. So probably the most important thing, I'll put a gigantic star here. This is the angle you work with. And we'll see in a few examples today what we're talking about. So that's the angle you work with. Notice the awesome handwriting I just had right there. So always start with the angle you work with, and then here's what the other letters mean. Don't forget side C is always across from the angle you're working with. So side C is the side across from the angle you work with. And then the other two sides, the sides A and B, are just, and maybe I'll use my vernacular that I learned growing up. These are the othering two sides of the triangle. So the other two sides. So in this case, here's the angle you're working with. There's the side across, so it would be c squared equals, and then pretty much everything else is relating to the other two sides on the right part of the equation. Okay, let's get going with one example right here. So this first example, we're trying to figure out what this side across from the 36-degree angle is. And let's jump through this checklist of methods. This is probably not a right triangle. If we look for law of sines, we have an angle side across from it, but we don't have an angle to go with either of the other two sides, so we can't really use law of sines here. So we have to jump to law of cosines here. So a good idea of what to do first, always identify the angle you're working with first when you're doing law of cosines. There's the angle you're working with, and there's the side across from the angle you're working with. So here's how this starts. This starts b squared equals, and then the other two sides squared. So 7 squared plus 5 squared minus 2 times 7 times 5 times cosine angle you're working with. Now at this point, you should be able just to plug everything in your calculator at once, and you get b squared, not just b squared is, keep it on your calculator, 17 point, and then a lot of other decimals. And then obviously square root both sides. So square root, second answer in your calculator, you get b is approximately 4.17, and then whatever unit this is. Okay, so pretty easy to start with. Just plug it on your calculator. Okay, next up, let's jump to an example like this. So in this case, we're finding an angle this time. And same idea, let's go through this checklist. If you're not sure, law of sines, law of cosines, which one to use, try law of sines first. That's usually the easier one to use. And if that doesn't work, jump to law of cosines. So in this case, we don't know if it's a right triangle, so we can't use a right triangle method. Here's an angle, side across from it, but we don't have either of the other two angles, so we cannot use law of sines. We have to use law of cosines. So identify what angle you're working with. In this case, we're working with this angle right here, and then that's the side across from the angle we're working with. So we have 16 squared, so across from the angle you're working with, equals 9 squared plus 10 squared minus 2 times 9 times 16, all times cosine x. Okay, we need to talk about how to solve this thing. There's a couple rookie mistakes you can make when solving this. So let's talk about one of them right away. Okay, here's how we're going to start. We're going to subtract 9 squared from both sides. We're going to take that over, and we're going to take the 10 squared and move it to the other side. So 256 minus 81 minus 100. 75 equals negative 180 times cosine x. A very common mistake is to take this 2, 9, and 16 and add it with the 9 squared and the 10 squared. But you can't do that because don't forget there's a big multiply sign right between those two. Think of it as if you're solving 7, or let's say 4 for example. 4 equals negative 6x. You wouldn't combine the 4 or the 6x. Okay, same idea as that type of equation. How you get, now don't forget your variable is cosine x. Your variable is not just x, your variable is cosine x. So we need to get cosine x by itself. So divide by negative 180, divide by negative 180, and you get cosine x equals negative 0.416, and the 6 repeats. Okay, don't forget from here, all you have to do, take an inverse cosine, and you get the angle is approximately 114.62 degrees, which makes sense. The cosine is negative. Remember, negative cosine happens in second and third quadrant, so it makes sense that our angle is bigger than 90 degrees. Okay, let's move on to another example here. This is a solving triangle example. Remember, solving a triangle just means get all the sides, get all the angles. So in this case, this is obviously not a right triangle, and if we try law of sines, we only have one angle, but we don't have a side to go with it. So basically, we don't have an angle and a side across from it, so we can't use law of sines. We have to use law of cosines to get the angle first. Well, in this case, we can't really get an angle either. We're going to have to get the side first if we're thinking law of cosines. Okay, so law of cosines, there's the angle, there's the side across from it. So the setup goes c squared equals 3 squared plus 2 squared, and then minus everything else. Punch it all on your calculator at the same time, and then square root, you get c is about 2.98. Okay, the next step, so we have all the sides, we need to get one of the angles, and don't forget, we still can't use any of those right triangle methods because this thing ain't a right triangle. So, we need to jump to probably, now, you could do another law of cosine, sure, but law of sines may be a little easier to do in this case. So let's use a law of sines instead. You can get angle B first, you can get angle A first, whatever you prefer, or in the vernacular, whatever your druthers are. So let's do law of sines here. And let's get angle B first. Okay, so to get angle B, we need to use the law of sines here. Could use law of cosines, but this will be easier. Sine B over 2 equals sine 70 degrees over 2.98, what we just found. Solve this out. You get sine angle B is 0.63 and then a ton of other decimals. Inverse sine gives you angle B is 39.1 degrees. And then you kids know by now, just subtract from 180 from the other two angles, and then you'll get angle A is about 70.9 degrees. Okay, let's just start another solving triangle example. In this case, we're given 3 sides of a triangle, so all 3 sides, and we don't have any angles. So in this case, we don't know if this is a right triangle. We can't use law of sines because we don't even have one angle, so we need to use law of cosines. And it doesn't matter for law of cosines, it doesn't matter what angle we get first since we don't have any of them. So let's just pick one. Let's just pick this angle right here, angle C, and figure out what it is. So the setup would be in this case, there's the angle, 9 is the side across from it, so the setup goes just like this. And then you guys know how to do this by now. Don't combine the 2, 7, and the 13 with everything else. Don't make the rookie mistake, and that's all I'm going to do on this one. Okay, one last thing we need to talk about and do just a very, very, very quick example is a very famous formula called Heron's formula. So this is how you get the area of a triangle if you only have the three sides. So Heron's formula says for any triangle, if when you calculate the semi-perimeter, just half of the regular perimeter, then the area goes S and then subtract S from A, S from B, S from C, and then multiply all the numbers together and square root. Okay, a very quick example goes like this. The distance as the crow flies from LA to New York is 2,451 miles. From New York to Montreal is 331 miles. And from Montreal to Los Angeles is 2427 miles. What is the area of the triangular region between these cities? Okay, so area, we can't do this with the law of sines formula we had last week, so we need to use this semi-perimeter or Heron's formula method. Okay, semi-perimeter go. Take all the numbers, divide by 2, and that's half the perimeter, so 2,604.5 miles. And then to get the area, just plug it in the formula, and you'll get around a little over 400,000 square miles. Don't forget, M-I-L-E translates to M-A-L-L if you're saying it. Okay, ladies and gentlemen, that's law of cosines. See you later.